Good morning, all of you. In this session, I am going to explain about these two problems related to friction. Okay. In this session, I will explain how to determine tension in the strings and pulling force required P. Before going to the problems, first of all, you have to know the fundamentals about free body diagrams. That this is a horizontal plane, this is a block. W is the self weight of a block. Now I am applying a pulling force P. Okay. Then the direction of motion of this block is towards right. Okay. Now, how to draw the free body diagrams? How to draw a free body diagram for this problem? First of all, you have to consider self weight W. So already we know that self weight of a body always acts vertically downwards, and the opposite reaction force is R. This reaction force always makes an angle 90 degrees with respect to the support. Here the support is horizontal, so the reaction force is vertical to the support. Okay. Now you have to consider this pulling force as it is. Here the direction of motion of this block is right side. Okay. Then you have to consider opposite frictional force. Okay. You have to consider frictional force in opposite direction. Okay. So here the direction of motion is right side. So you have to consider left side direction for friction. Okay. This is the applied pulling force. Okay. Now you have to consider these two forces here. Okay. This is the complete forces diagram. Okay. This is a free body diagram for this problem. Okay. So by using these fundamentals, you have to solve this problem. Okay. The given question is capital A is a 100 newtons block and B is a 200 newtons block as shown in figure. Okay. Capital A is a 100 newtons block and capital B is a 200 newtons block as shown here. The block A is attached to a string capital T to a vertical wall. Okay. Now the coefficient of friction between the block A and B is 0.2 and the coefficient of friction between the block B and the horizontal floor is 0.3. Then calculate minimum force required to move the block B. Okay. Calculate minimum force required to move the block B. Okay. This is a given diagram. So from this diagram, first of all, you have to identify the given values. Here, the self weight of a block A is 100 newtons and the self weight of a block B is 200 newtons. Okay. And capital R is the reaction force between the contact surfaces. You have to consider R1 for reaction force between the block A and B. Okay, R2 is the reaction force between the block B and support. Okay. So here mu1 is the coefficient of friction between the block A and B. Yeah, from the given question, the coefficient of friction between A and B, block A and B is 0.2 here. between these two surfaces, the mu value is 0.0.2. Okay, so mu value is 0.2 between the block A and B. In similar way, between the floor and the block B is 0.3. Here, between block B and the floor is 0.3. Okay, so let's consider the coefficient of friction between block B and the floor is mu2 equal to 0.3. Okay, now the friction force between the block A and B. Yeah, yeah, this is the frictional force between the block A and B is F1, F1, and the friction force between the block B and the floor, horizontal floor, is F2. Okay, these are the given values. From the given values, you have to identify the direction of motion of the blocks. Yeah, from these details, you have to determine the pulling force required. The pulling force required to move the block B in right side direction. Okay. Now, I am showing the direction of motion of the blocks. Yeah, the direction of motion of this block B is in right side direction. At the same time, due to friction between the block A and B, the direction of motion of the block A is opposite to the direction of motion of a block B. Okay, both are in opposite direction. Okay, okay. From these values, you have to determine the minimum force P required to move the block B in right side direction. Okay, you have to calculate a minimum force P. Okay, first of all, you have to draw a free body diagram for this problem. Okay, now I am considering these two blocks as it is. Now W1 is the weight of a block A. Okay, W equal to 100 newtons. That is the self weight. Self weight always acts vertically downwards. Okay, so W1 is the self weight of a block A. Okay, and similarly, you have to consider self weight of a block B. Okay, 200 newtons is the self weight of a block B. Okay, W2 is the self weight of a block B. Okay, now you have to consider reaction forces. Okay, already we know that reaction force always induced at the point of contact between the two surfaces. Okay, here the block B and the floor. Okay, between the block B and the floor, you have to consider reaction force R2. Okay, in similar way, the reaction force between the block A and B is R1. Okay, so here R2 is the reaction force between the block B and horizontal plane. Already we know that reaction force always makes an angle 90 degrees with respect to the support. So this is a horizontal support. So you have to consider 90 degrees. That means you have to consider vertical reaction force between the horizontal support and block. Okay. Now you have to consider reaction force R1 between the block A and B. Okay. Here from the given diagram, first of all, you have to identify the moving surfaces and fixed surfaces. Okay, this bottom surface is this bottom horizontal floor is a fixed surface. Okay, there is no motion, and block B and A both are movable bodies. So here this is a fixed surface, this is a bottom moving surface. Now this is a top moving surface, this is a bottom moving surface. So here at block A and B, the common surface is this one. Okay, so you have to consider two equal and opposite reaction forces at A and B surface. Okay, these two are movable surfaces. Okay, these two are movable surfaces. So you have to consider two equal and opposite reaction forces. Okay, for this block you have to consider vertically downward reaction force. For this block you have to consider vertically upward reaction force. These two are equal and opposite. Okay, these two are the equal and opposite reaction forces between the block A and B. Okay, now you have to consider direction of motion of the block B and direction of motion of a block A. Okay, from this animation diagram you can observe the direction of motion of this block B is right side direction. So you have to consider left side reaction force for bottom surface, and also you have to consider frictional force between the block A and B. Okay, so this block will move in right side direction. So you have to consider left side frictional forces. In similar way, you have to consider this block. The direction of motion of this block is left side. Okay, due to friction between the block A and B, this block moves backward. Okay, so you have to consider the direction of motion of the block A is left side direction. So you have to consider friction force at this surface in right side direction. Okay, always you have to consider friction force opposite to the direction of motion of the block. Okay, so here the direction of this block is left side, so you have to consider right side frictional force. In similar way, for this block B, the direction of motion of block B is right side, so you have to consider left side frictional forces here. Okay, so this is the free body diagram for this problem. Okay, now you have to consider free body diagram of a block A for determine the value of tension T in the string. After that, you have to consider free body diagram for block B. Okay, for determining the value of P. Okay, in case one, you have to consider equilibrium of block A of weight W equal to 100 Newton. That is upper block. Okay, so you have to consider free body diagram for this block A. Okay, in case one, you have to consider free body diagram for block A. Okay, so W1 is the self weight of a block A, that is 100 newtons. R1 is the opposite normal reaction force between the block A and B. Okay, now you have to consider tension in the string. Okay, T is the tension in the string. Okay, this is a horizontal string, so you have to consider tension in the string. Now you have to consider direction of motion of the block. Here the direction of motion of this block is left side direction, so you have to consider right side frictional force. Okay, now you have to consider two parallel axes. So sorry, two reference axes. One is parallel to the horizontal plane, other one is vertical. So these two are self weight and reaction force. This one is the friction force, and this one is tension. Okay, this is a free body diagram for this block A. Okay, already we know that resolve all the forces along the horizontal axis, and also you have to resolve all the forces along the normal axis. Now you have to consider frictional force between the block A and B. from given data, the frictional force between block A and B is 0.2. That is mu1. Okay. So sum of all vertical forces equal to 0. So here for upward action, you have to consider positive sign. For downward action, you have to consider negative sign. Okay. Plus R1 minus 100 equal to 0. So the reaction force between the block A and B is 100 newtons. Okay. Now resolve all the forces along the horizontal axis. Okay. Here for left side direction, you have to consider negative sign. For right side direction, you have to consider positive sign. So capital T equal to mu1 R1. Now already we know that the mu1 equal to 0.2 and R1 equal to 100. So tension in the string T equal to 20 newtons. Okay. From this diagram, we got a tension in the string and a normal reaction between the block A and B. Okay. In second case, you have to consider free body diagram for block B. B of weight W2 equal to 200 newtons. Okay. So this is a block B. You have to consider free body diagram for this block. Okay. So W2 is the self weight of a block B. Okay. Self weight always acts vertically downwards. And R2 is the normal reaction force. Okay. Perpendicular to the support. Okay. Now R1 is the normal reaction between the block A and B. Okay, now you have to consider direction of motion of the block. Okay, this is the direction of motion of the block. Okay, now you have to consider left side direction for friction. Okay, this is the frictional force between the block B and horizontal floor. And this is another friction between the block B and block A. Okay, frictional force between the block A and B. Okay. So already we know that the direction of the frictional force is always opposite to the direction of motion of the block. Okay. Now consider horizontal and vertical axis, reference axis. Now you have to consider self weight W2 equal to 200 newtons and reaction force R1 and R2. And you have to consider this friction force F1 and F2. Now you have to consider this applied force P. You have to convert this applied force P into two components. One is a horizontal component and the other one is a vertical component. So P here, the angle is 45 degrees with respect to the horizontal. So you have to consider cos theta for X component, sin theta for Y component. Okay. So P cos 45. From this diagram, you can observe this force lies in first quadrant. Okay. So the X component is P cos 45 and Y component is P sin 45. Okay. Now this is the free body diagram for the block B. Now resolve all the forces normal to the plane. So here mu1 equal to 0.2, that is friction between A and B. And mu2 equal to 0.3, that is the coefficient of friction between the floor and block B is 0.3. Okay. From case 1, the reaction force R1 equal to 100 newtons. Okay. This value obtained from case 1. Okay. Substitute these three values in the free body diagram. Okay. Resolve all the forces normal to the plane. Okay, that is the sum of all vertical forces equal to 0. For upward direction, you have to consider positive sign. For downward direction, you have to consider negative sign. Okay. So plus R2 plus P sin 45 minus R1 minus 200 equal to 0. Okay. From this equation, normal reaction R2 equal to 300 minus 0.707 into P. Okay, P is the effort required to pull the block B. Okay. Now resolve all the forces along the horizontal axis. Okay. These are the components. These are the forces lies on x axis. Okay. For right side direction, you have to consider positive sign. For left side direction, you have to consider negative sign. So the P cos 45 minus mu2 R2 minus mu1 R1 equal to 0. Okay. Substitute value mu1 equal to 0.2, R1 equal to 100, mu2 equal to 0.3, R2 equal to 300 minus 0.707 into P. Okay. From this equation, you have to find out the value of P. That is effort required to pull the block B. P equal to 119.69 newtons. Okay, this is the answer for this problem. So the minimum effort required to drag the block B is 119.69 newtons. Okay, this is the final answer for this problem. Okay, now coming to the another example, what should be the value of the angle alpha in figure so that the motion of the block 90 newtons impends down the plane? The coefficient of friction between all the surfaces is 1/3, that is 0.33. Okay, from this given question, you have to determine the value of alpha, that is the angle of inclination of the inclined plane, alpha. Okay, the given values are weight of the block, upper block W1 equal to 30 newtons, weight of the block B, that is the lower block, W2 equal to 90 newtons. Normal reaction between the contact surfaces equal to R. R1 is the reaction force between the block A and B, and R2 is the reaction force between the block B and inclined support. Okay. Mu1 is the coefficient of friction between the block A and B. Mu2 is the coefficient of friction between the block 90 newtons and inclined surface. Okay. Frictional force F1 equal to mu1 R1, F2 equal to mu2 R2. Okay. Alpha, angle of inclination of the plane, alpha. Okay. These are the given values. So let's consider this block as A, this block as B. Okay. The self weight of a block A is 30 newtons and the self weight of a block B is 90 newtons. Okay. Now, the coefficient of friction between the block A and B is 0.33, that is a mu1, and the coefficient of friction between the block 90 newtons and this inclined plane is 0.33. Okay, and the normal reaction between the block 90 newtons and the inclined plane is R2. R2 is the reaction force between the block 90 newtons and the plane, and R1 is the normal reaction between the block A and B. This is R1 reaction force. Okay, and the friction force between the block 90 newtons and the plane is F2. Okay, F2 equal to mu2, R2 is the friction force between the block 90 newtons and inclined plane, and F1 is the two equal and opposite frictional forces between the block A and B, that is F1. Okay, F1 equal to mu1 R1. Okay. So from the given values, you have to determine the angle of inclination of the plane, alpha. Okay. First of all, you have to identify the direction of motion of the blocks. Okay. Let's consider the block B moves downward. Okay. Due to self weight. Okay. Here there is no actional force. Okay. So here when the block B is moving downward, then the block A moves in upward direction due to friction between block A and B. Okay. Now you have to consider free body diagram for this condition. Okay. Let W1 is the self weight of a block A, that is 30 newtons. W2 equal to 90 newtons, that is self weight of a block B. Now you have to consider reaction force between the inclined plane and the block B is R2. Okay, R2 is the reaction force between the block 90 newtons and inclined plane. In similar way, R1 is the reaction force between the block A and B. Now you have to consider two equal and opposite reaction forces between block A and B, because these two are the, here there are two moving surfaces. Okay, so you have to consider two reaction forces. Okay, for each moving surface. For each moving surface, you have to consider one friction and one reaction force. Okay. Now you have to consider direction of motion of this block B as a downward direction. The direction of motion of this block A is opposite to the direction of motion of a block B. Okay, both are in opposite direction. Okay. Now you have to consider frictional force. Frictional force between the inclined plane and the block B is F2. F equal to mu 2 R2. And also you have to consider friction force between the block A and B is F1. F1 equal to mu 1 R1. Okay, here the direction of motion of the block is downward. So you have to consider opposite frictional force. Okay, frictional force always opposite to the direction of motion of the block. Okay, here this block is moving downward. So you have to consider two frictional forces. These two frictional forces in upward direction. Now you have to consider the direction of motion of this block A as upward direction. So you have to consider downward frictional force. Okay. So these two are in opposite direction. Okay. Friction force and direction of motion both are in opposite direction. Okay. So this is the free body diagram for this problem. Now here T is the tension in the string. Okay, tension in the string. T is tension in the string. In case 1, you have to consider free body diagram of a block A, that is a 30 newtons block. Okay, so this is a 30 newtons block. Okay, now you have to consider free body diagram for this block A. First of all, you have to consider two reference axes. One is parallel to the inclined plane, other one is normal to the inclined plane. Okay, now you have to consider self weight of a block A equal to 30 newtons. R1 is the reaction force between the block A and block B. Okay, now you have to consider tension in the string, that is T. T is the tension in the string. Now you have to consider direction of the motion of the block. Already we know that the direction of motion of this block is upward direction due to friction between block A and B. Okay, so you have to consider frictional force opposite to the direction of motion of the block. Okay, so this is the frictional force between the block A and B. Okay, now you have to draw free body diagram for this block. Okay, these two are the reference axes. You have to consider self weight W. You have to convert self weight W equal 30 newtons into two components. That is one component is parallel to the plane, other one is normal to the plane. Okay, here the angle of inclination of the self weight 30 newtons with respect to this normal axis is alpha. So you have to consider this one as adjacent side. For adjacent sides, you have to consider cos alpha. For opposite sides, you have to consider sin alpha. Okay, so these two are the components for self weight 30 newtons. Okay, for adjacent sides, you have to consider cos alpha. For opposite sides, you have to consider sin alpha. Okay, now you have to consider normal reaction as it is. Now you have to draw this friction force F1 equal to mu1 R1 and tension in the string T. Okay, so this is the free body diagram for block A. Now you have to resolve all the forces normal to the plane. So mu1 is the coefficient of friction between the block A and B. Sum of all vertical forces equal to 0 plus R1 minus 30 cos alpha equal to 0. For upward action, you have to consider positive side. For downward action, you have to consider negative side. Okay. So reaction force R1 equal to 30 cos alpha. Here the angle alpha is not given. You have to determine that value. Okay. After that, you have to resolve all the forces parallel to the plane. For right side action, you have to consider positive side. For left side action, you have to consider negative side. So 30 sin alpha plus mu1 R1 minus T equal to 0. Here from this equation, the tension in the string T equal to 100 cos alpha plus 30 sin alpha. Okay, let this equation as 1. Okay. Now you have to consider second block, that is a block B. Okay, in second case, you have to consider this block B. Okay, first of all, you have to consider reference axis. One is parallel to the inclined plane, other one is normal to the inclined plane. W2 equal to 90 newtons is the self weight of a block B, and R2 is the reaction force between the inclined plane and block B. R1 is the reaction force between the block A and B. Okay, R1 is the reaction force between the block A and B. Okay, now you have to consider direction of motion of the block. Okay, here the direction of motion of this block is downward direction. So you have to consider opposite frictional force. So you have to consider upward frictional force at the contact surface. Okay, this is the friction force between the inclined plane and block B, and F1 equal to mu1 R1 is the frictional force between the block A and B. Okay, both are opposite to the direction of motion of the block. Okay, now you have to draw free body diagram. First of all, you have to convert this self weight W equal 90 newtons into two components. That is a 90 cos alpha, 90 sin alpha. Okay, these two are the components for self weight W2. Now you have to consider reaction force R2 and R1 as it is. Okay, now you have to consider frictional force F1 and F2. Okay, so this is the free body diagram for this block B. Now resolve all the forces normal to the plane. Okay, already you know that from given data, mu1, mu2 are the coefficient of frictions between the contact surfaces. Okay, R1 is R1 is equal to 30 cos alpha. Okay, this value is obtained from equation from case 1. Okay, so R2 plus R2 minus R1 minus 90 cos alpha equal to 0. From this equation, we can get the value of R2. R2 equal to 120 cos alpha. Okay, so R2 minus R1 minus 90 cos alpha. Here the R1 value is 30 cos alpha. Okay, 30 cos alpha minus 90 cos alpha equal to 120 cos alpha. Okay, now resolve all the forces parallel to the inclined plane. Okay, these three are the forces lies on or horizontal axis, that is x-axis. For right side action, you have to consider positive sign. For left side action, you have to consider negative sign. So 90 sin alpha minus mu2 R2 minus mu1 R1 equal to 0. So 90 sin alpha minus 0.33 into 120 cos alpha minus 0.33 into 30 cos alpha equal to 0. Okay. This is the value of R2. This is the value of R1. Okay. These are the coefficient of frictions. Okay. From this equation, tan alpha equal to 0.555. Okay. Now alpha equal to tan inverse of 0.55. Okay, alpha equal to 29.05 degrees Celsius. Sorry, degrees. Sorry, alpha equal to angle of inclination of the plane equal to 29.05 degrees. Okay, 29.05 degrees. Okay. Now from equation 1, the tension in the string T equal to 23.309 newtons. That is the tension in the string. Okay. This is the value of tension in the cord or string. Okay. So this is the final answer for this problem. Okay. In next class, I will explain more problems on ladder frictions. Ladder friction. Okay. Okay. Thank you.